Thank you. Hello, everybody. Thank you for attending our presentation, either here or online. So first of all, I will say that it's our first time to attend the Semantic, so we are very happy about that, and we already saw a lot of interesting presentation, and we want to thank all presenters for that. We hope our presentation will fit nicely in the program. So my friends and colleague here, Yoann Goudin, is most interested in didactics and multimodality when I'm a kind of computational linguist. And what brings us together and what brings us here is an interest for the Chinese script or Han script and its relation with a variety of languages and some teaching aspect. So in this presentation, we will have two parts. Yoann will talk about more teaching aspects and historical and philological aspects, and I will try to present a few propositions of computational models to capture what Yoann will be talking about. So I will.
Thank you. 大家好. So I will briefly start in order to understand the second part of the presentation, who will be more technical, with some very general aspects about Chinese writing. And if you already know, it's fantastic because it will be a very nice opportunity to discuss and argue about it. So here is the Chinese, and thank you for the presentation of today, because I will deal with this particular sinogram, which is Fu, and translated as happiness. With a very general introduction, as of course you know there, but not in class, and even among colleagues, that Chinese characters are not ideograms, as De Francis claimed, and you already quoted him many times in this, but in class, they are still ideograms. So our first representation to face is this kind of representation for the learner. For example, here it's just pictograms and the evolution of pictograms, which is the very first contact with the Chinese writing system in class. But then you got this kind of adequation between the language you learn and the writing system you write with, and with assertions such as Chinese writing is now as a 5,000 years long history, but it's not attested that the signs on these symbols here or here, taken from bolts, are related with the language which is now became Mandarin Chinese, which is the language I teach in Paris this year. But from this particular period, which is 100,000 years and 4 centuries before Christ, there was this divination oracle bone for divinations. And these signs, we were the comments about the divination, were the very first signs we could relate it with the language spoken at that time. And how do we do so? I will give you this example. This is supposedly a pictogram, but can you recognize that it's a bat? Now, I told you, you can see that it's a bat, but do you think that it's because there is a bat into the divination, or it's just because they want Batman to come? No, actually, it's just homophony. And it's related with the very character we saw this morning. But as you can see, it's not the same. Why so? Because this is what this sign became after, when the writing system was standardized, with homophony and the discrimination of homophones, with the adding of discriminant components, here for the bat and here for what we call now happiness. And how do we know that it's the same language? Because now again, it's pronounced exactly the same as Fu, which is the possibility to go back in the past and to be sure that on these turtle plastrons, the language was related to what we learn and teach today. So this is quite different. It's a very typical explanation of the different components with, in order to make us memorize sinograms, which is supposed to be a vessel, and this vessel and the altar, in order to back to religion and divination. So this is not related with what I just explained, but this is the two main speeches confronting in class. I was given an example through Mandarin Chinese, but it's exactly the same with different Semitic languages. And here you have, you can see with these transcriptions that it's very close. And the same for what happened in sinogrammic languages such as Japanese, Korean, and Vietnamese, who was the first to borrow the Mandarin, the Chinese reading and vocabulary. So, just in order to sum it up, here we have after bolts, we have the three steps of evolution. First, the zodiograph, which is the pictogram, then the determination step, and then you have many other sinograms to be designed, always on the same principle, which is sound and not meaning. Example with what we call, so through this you got the determination, and here in the contemporary lexicon, the few syllables with determinant components who are still readable in Chinese nowadays. So here is from the very first corpus with the titled plastron. Here is 2nd century after Christ, and here is a 12th century. And what you can see is that here is the proportion of these phonetic compounds, which is, as you can see on this data, quite important because it's about more than 90% over 24,000 types of characters in this song dictionary. So here is, to summarize it, is that you got this writing, which is just an orthography of what the language who was written 2,000 years ago, because every Semitic languages originated from the language of that time. And we miss, through this writing system, we miss many phonetic phenomena, such as tones. The tones appeared after the economic rules of the graphic system was standardized. So here is the two very important steps. Here is the Shouwen Qiezi, who was the first lexicographic data-based dictionary sum up in the 2nd century of after Christ. And this is a very important institution because it was in this particular work that the radical, so the so-called semantic component, raised as just the key of indexation. And then we have to wait for the 28th century before this radical became the institutional way of indexing. Sinograms into dictionaries. So here is a distribution between the different keys in that particular dictionary, the Kangxi dictionary of the 18th century, sorry. And here is the, in order to see how many there are. And, sorry, this is the end. Ooh, what happened? Oh, here I am. So what is a radical? Historically, as we can see, we could see, it's a discriminant component in order to discriminate mainly homophones, a key for indexation in dictionaries. And now the problem is it a semantic clue? And the other part, a phonetic one. So for the phonetic one, it's already published as this paper with Pierre already. And now we will see how we do in order to see if semantic clues are really are.
Okay, plenty of time. So as you can see, we're interested in diving into the internal structure of the sinograms. And we have these two main two main dimensions. One is phonological, and the other one would be related to meaning broadly. And for my part, I won't discuss the indexing function of the radicals because it's obvious and it's just a convention. But this conflict between phonological and semantic deserves more investigation. So what I'm trying to do is to provide empirical evidence and measurements for these two dimensions. We hope to provide something that would, some method that would be data-driven, that would rely on synchronic data, so from language of nowadays that are easily collected, and that can be applied in a multilingual fashion, because as we saw, the sinograms concern many different languages. So what we expect to obtain are this kind of ranking generator, so we can adapt our discourses and teaching materials and enrich the description of the Han script. So luckily, we arrived at a time of open data. So I apologize for all the missing references, but I will provide them at least in the paper, or you can ask me. But we rely a lot on data that has been provided and worked on by other teams, especially the data for decomposition by the Chise project, and some lexical data from the Ministry of Education in Taiwan, which allow us to build some, it's not very clear, but to build some lexical graphs that goes from the basic component to its composition to another component, which may be a sinogram or not. And if it's a sinogram, it may have different readings. And this allows us to design some measurement that draw from the information theory. And the intuition, I won't give a lot of mathematical details. I will try to give you the intuition behind the computation. So for the phonological part, it's quite simple, I hope. The idea is that if a component contributes to the sound, to the reading of the resulting sinogram, then the fact that you know the component is here or not will bring you information on how you should read it. So if I ask you to guess the reading of a sinogram and I don't tell you anything about it, you can only rely on the general distribution of the language. So here, I did all the computation on Mandarin, but you can transpose to other languages. And if I tell you that, okay, you have to guess a reading, knowing that the sinogram contains this or this component, and then we can measure the change of probabilistic distribution, and it's called information gain. And we rely on this to order all the components and to see which characters are constructed with those components. And as you can see, if I look at the top of the list, I may find some very rare sinograms. Most of them, to be honest, I don't know. But you can judge the reading by the opinion here. They are very consistent. So that's exactly what we want to detect automatically. And on the other end of the list, at the very end, you will find all the radicals. So it's not really a finding that the radical has no phonetic contribution, but it's at least consistent. And what is interesting for us, it's of course the top of the list. So this was a work done a few years ago, and now I turn to meaning, which is a little bit more difficult to grasp. So one first strategy to manage to grasp the meaning is to rely on synonymy datasets. So a few years ago, when I was working in National Taiwan University, we built some big synonym graphs. And in this kind of graphs, it's well worked on. We can spot clusters of meanings. So the main idea is that if the radical is bringing some meaning to the words and to the sinograms and the words it occurs in, then if you look at the distance in this graph, the distance between words that share same radicals should be smaller and significantly smaller than the distance between two random words. And so we can easily build that model and do some statistical testing to sort all this. And if you see, you can see the basic result here is that we can find some significance, but only for a small subset of radicals, which are here in green. So for those who know a little bit of sinograms, whatever the language, you will recognize things like the grass or food, this kind of very clear meaning. And some are absent and we could expect them, like the hand or stuff like that. So this was a method that seems to be working, but one issue is that it's working on Mandarin, but to apply the same computation for other languages, it's a bit difficult because the graph is not easy to build. So another proposition is to rely on more shiny, brand new, large language models that you can find in all NLP papers these days, such as BERT, which are models that are designed to guess masked sinograms. So you take a text and you ask the model to guess which character should be in that position. So the idea, again, here is that if the radical is bringing some meaning to the sinogram, then this kind of language model should fill the gaps with other sinograms, but with the same radical. So to see the computation by example, so you take some text, you put it into a column, you ask this language model to guess what are the other sinograms that may go in that place. Then you filter a little bit because, as you can see, it's always you have the same character. It will often guess the same character, which is kind of correct, but not interesting for me. And I have also to do some filtering about simplification and stuff like that. And after that, I turn all those sinograms, I replace them by only the radical, and I compute probability ratio on this data. And I can obtain the same kind of output, which is some higher ratio for more significant, semantically more clear radicals. So here are some examples with the score, which means, like, for example, if you try to replace a sinogram which contains the radical of the food, so you have 18 times more higher chance to draw another sinograms with the same radical of the food. But lots of radicals that you would expect, because from the etymological point of view, they have some clear meaning, but they don't have a real contribution on synchronic data. So this is obviously a work in progress. So we want to apply this methodology on other languages, which bring us to maybe lighter language models. So it's easier for the minority languages, and try to assess for the stability of the model on other corpora. And and do some experiment with simplification of the script. And since it's close to the end, I will.
Close to the end. And as a conclusion, thank you. Okay. Back in the classroom, because as you can hear through our French accent, the situation we are describing is really the situation of Chinese as a foreign language in France, because we do not read in English such as differences. So there is this really problem in class. And that's why the teaching is always radical oriented. And that's why we wanted to prove, not just for you, but also for our students, that our learning has to focus on components and to deal with the function of the different components. Because most of the time, linguistically, the most reliable component will be the phonetic one. And the other one will be the discriminant for the reading. even if, as Pierre just demonstrated, it's somehow there are semantic clues. So for the components, yep, and the same for the phonetic clue. And what we intend to do is to document the sinograms and the entire lexicon, whatever the language, in order to demonstrate to our students that through these cues, what is the most consistent for them in order to learn these languages. So here is the end of our presentation. Thank you for your attention and your questions.
Thank you. Well, I have a remark by Richard Sprout.
Yeah, so I'm wondering if BERT isn't a bit of overkill, right? If you were to use a smaller language model, you probably, for example, you could do it on the Academia Sinica historical corpus and maybe get something that's a little closer to the meaning. Obviously wouldn't be necessarily relevant for modern day usages of characters, but it may actually be closer to the historical uses of those characters and maybe better for your purposes.
I totally agree. And to echo the presentation of yesterday, I come from computational linguistics and natural language processing, and I had few papers that were refused on the only basis that I did not use BERT. So look, I decided.
Well, I sympathize with you there, yes.
And then I start with BERT, and now I want to see if I manage to get this at least the same kind of result with a simpler model. And,
right. I mean, I think the right answer to that objection is to do exactly what you're doing and show the reviewers that BERT isn't good for everything.
We have a question by Cornelia Schindelin.
Well, thank you. I'm still pondering what you are doing there and what is going to lead to. And I just want to remark that radicals are quite an arbitrary thing. And especially the Kangxi-Zhidian radicals are pretty idiosyncratic in some places. So is that really a useful sort of radical? I mean, there are hundreds of radicals lists around, and I'm somewhat familiar with the simplified characters and radical systems on the mainland. For me, from my point of view, Kangxi-Zhidian radicals are something of the past. So that was the first thing that is kind of busying me right now. Also, I wonder if you're familiar with the research by Andreas Goudin. What was his last name at that time? Goudin 1998, who did some research not on the radicals, but on the components, asking or trying to figure out what the semantic load of the components was to figure out which ones were really be able to be called significs, or you had a different term, I think a French kind of term a minute ago, which I somehow didn't really take down. So I mean the Ifu or the Xingtang. Also, the present shape of the radicals has been influenced by the Li variation of Han times and somewhat before and after that, mostly Han times. So I wonder how much you took that into account in your research here. Thank you. I'm sorry if this is somewhat confused. I'm still thinking about what you presented us. Thank you.
Thank you for your comment. And of course, we know this work, but if it's relevant into the German context, because it's written in German, the problem is that it's not known out of Germany, and this is another problem. And we know this work, but not access in a French classroom. Even differences through this very easy facts and fantasy is not famous in France yet. So we have a lot of work to do in that direction.
A question from the audience.
Hi, this is Rachel Garten. I love this. I've been very interested in this topic as well because I used to teach Japanese in the United States, and students have similar problems learning the characters. I had just two kind of, I guess, questions. First, how did you consider the different variants of the radicals, and how did that influence the model?
Yes, because we rely on already available data sets. And so to find, actually it echoes the previous question, to find what sinogram contain which radical, we have two different strategies. One is to simply rely on the data from the Uniran dataset, from the Unicode, which basically is the content of the Kangxi Zidian. And the other one is to just forget about the idea of radical and just focus on components and use all the possible components in the IDS from Chise project. Yeah.
Thank you. And my other question was, I'm not sure how this would work with a model as opposed to applying it in the classroom, but I know that there are certain memory models, like dual route model, for example, where the idea that something that represents a concrete entity is easier to remember than an abstract concept. I'm not sure, I think Paivio is a famous scholar in that area. And so I've always wondered, would that influence with radicals and memorizing if the semantic component represents a physical item as opposed to an abstract concept, if the memory cue, I guess, ability to memorize would be any different. I don't know if you have any thoughts on that, but I've always wondered this myself. So,
I think the food is very concrete. Because there may be some connection between which radical is a reliable semantic clue and which one is more concrete, because it's more obvious to and easier to mark the meaning. So if you, I can't find it here, but it's somewhere, the radical for food or some other, the grass, stuff like that, are more concrete and they tend to be more significantly contributing to the meaning.
Thank you. Yes, thank you.
And thank you for your question from Japanese, because it's not a problem just for Mandarin, it's just as foreign learners. The problem is that as soon as we have to learn Chinese characters, we have to go beyond our presentations. And your question is very interesting. It's also because in Japanese, you got Japanese simplification. We also have in China, in Mandarin Chinese, especially in mainland China. And the point is that some simplification do not rely on consistent radicals. And we can compare with what the historical process in Japan, because the Japanese simplification, if I am not wrong, and correct me if it's not, if I am, it's more consistent in order to conserve the phonetic clue, which is not the case in many Chinese simplifications. So for teaching, it's more interesting to compare with Japanese.
No more questions. Thank you very much. Thank you.